A formal language is a set of all strings on which we can apply some conditions during their construction. Let's consider some examples to make things clear. Let's say there is an alphabet 0, 1 and given a language L1 in which the strings are like 0, 1, 0, 0, 0, 1, 1, 0, 1, 1 are defined. Any any string other than these will not be accepted, like 1, 1, 1, 1, 0, 1, 0, 0, 0, 0, 0, 1. All these are not in the language. Only these strings are in the language. Let's consider another example, L2. Here we can see that each string should be of the form 0 power n, where n is greater than or equal to 1. So let's write what all the strings are there in the language. So the strings like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and so on. All these strings of this format will be in this language. Any string other than this format will not be in this language. Let's consider L3. L3 states that all the strings of the form of the pattern 0 power n followed by 1 power n, where n is greater than or equal to 1, are in this language, like 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1, and so on are in this language. Any other string other than this format, this pattern, will not be in this language, like 1, 0, 1, 1, 0, 0, 0, 0, 0, are all these are not in the language. They are not in this language L3. Let's consider another example, L4. In this L4, the each string should be of this form, in which 0 power n followed by 1 power n followed by a dollar followed by 1 power n and followed by 0 power n. So each string should be of this form. Let's write the strings, list of strings which can be in this language, like 0, 1, dollar, 1, 0, 0, 0, 1, 1, dollar, 1, 1, 0, 0, 0, 0, 0, 1, 1, 1, dollar, 1, 1, 1, 0, 0, 0, etc. Any string which is not following this format will not be in the language, right? So in the whole example, we have considered alphabet sigma is equal to 0 and 1. So each the language, we'll talk about this alphabet soon in the video lectures. We'll look at what is an alphabet, what is this symbol, what is the terminal. All these things we'll look at in the further lectures. Now let's look at the types of formal languages. Based on the structure of the language, structure of the strings, we can define the formal language into four types: type 0, type 1, type 2, type 3. Type 0 is also called as recursively enumerable language. Type 1 is called context sensitive language. Type 2 is context free language. Type 3 is regular language. We'll look at all these languages and the corresponding grammars and the corresponding machines which can be used to recognize these languages in the further lectures. A formal grammar, or simply a grammar, is a set of rules used for generation of a string. So these are the rules or productions which are used to generate a string in a particular language. So This grammar G states that S is the start symbol here, derives AB, in which A derives A and B derives B. For simplicity, let's write this complete thing in a tree structure. S derives A, B, and A derives A, B derives B. So this grammar G generates a string AB. So language LSL. So the language L has a string AB. This is how we generate a language, generate a set of strings in the language using the grammar, given grammar. So grammar is a generating device. Since we are generating a set of strings in the language, we call the grammar as a generating device. Let's look at all the types of grammars. So these are the types of grammars. Based on the structure of productions, we classify the grammar into four types: type 0, type 1, type 2, type 3. Similar to the types of languages, we have the corresponding grammars: recursive enumerable grammar, context sensitive grammar, context free grammar, and regular grammar. We'll look at these grammars and the corresponding languages in the further lectures. Now let's take a look at the automata. Automata is a mathematical representation of a formal language. It is a machine which can recognize a language. Let's look at the types of automata and then go to the relation between the automata, language, and the grammar. Based on the accepting power, we classify the automata into four types: Turing machines, linear bounded automata, pushdown automata, and finite automata. These are the machines which through which we can recognize, accept or reject any language, any particular language which we have talked about earlier.